in the chat if you are here, and cannot wait to get started with this lesson with you all. Just want to see who's here so I can say hello to a few of you. And for this lesson to go nice and smoothly and for you to enjoy it, please make sure you're responding in the chat, getting involved so that it goes nice and smoothly for you. We have a few people in the chat. So Gamer Noob, hello Gamer Noob. Welcome to the free lesson on particle theory today. Anybody else here? Say hello in the chat. Let me know if you can hear me as well. We are about to get started. Just want to see who's here before we get started, and I'll let you know a little bit about myself as well. So we have Gamer Noob 124 here. Yeah, well done for mentioning yourself in the chat. Thank you for saying hello. Hello to you. Anybody else here? Yeah, Mavis will be joining us today. Hello, Mavis. Anybody else in the chat? Yeah, make sure you respond in the chat. Otherwise, the lesson won't be as interactive for you. And the whole point is to make it as interactive as possible. So please don't be shy. Always mention what's happening in the chat. Get involved, and that will be great. So we have Zimchi here. We have Zerin. We have Adrian as well. Yeah, perfect. Hello, everybody. Hello, Hashir. Yeah, introduce yourself in the chat. I am going to introduce myself very quickly as well. Yeah, we've got Shania. Yeah, good stuff, Shania. And I am good. Hello. Neil does crying over AQA. So moving on. Hello, Viran. I'm going to tell you a bit about myself, guys. Yeah, so just give me a second here to tell you who I am. So my name is Emmanuel Opoku, as you can see over here. And you can call me Manny. That's absolutely fine. I have had 5 years of teaching experience, and two of those years I have been teaching in as the role of head of chemistry, and I've also had the role of study club coordinator as well. And I studied chemistry at Imperial College London. Hello, Elvis. Hello, Tarangani. Yeah, lots of people in the chat now. That's great. And there is a workbook. The link is in the description. So look in the description. You should see the link to the workbook. There definitely is a workbook here. And then we are also looking at the fact that I am studying a master's in STEM education, nearly finished that here. So we're going to get started. But before we get started, I don't want your friends to miss out on this free lesson that's going to be absolutely fantastic for you. It should be content that you already know, and it is a very solid foundation that you need for year 9 chemistry. So I'm going to teach you about the particle theory. But if you know anybody who would be interested or might benefit from this here, it's free. So you can just go to YouTube, click in the address bar, copy, and send it straight to your friend. So if you want to do that right now, feel free to do that. They can join at any point in the lesson. It should be absolutely fine. Okay, so moving swiftly on. And yeah, Neil does crying over AQA. Don't worry if you're not able to print it. You can do it on a piece of paper as well. It's a free lesson, so it's quite easy. Yeah, if you haven't been able to print it, it's not a problem as long as you have something to follow on with. Okay, so to get started here, if you want to have a look at these examples, we've got honey, we've got earth, juice, water. You can see the examples over there. What I'd like you to do in the chat, I'll show you an example. Hello, elite. You can say sugar, for example, is a solid. Let's see how you get on. And do that for the examples on there. If you finish, I give you a challenge to do any of the other ones there in terms of any ones you can think of and what makes you decide where it goes as well. So have a go in the chat. It'll be nice to see what you guys are thinking. And yeah, the workbook is in the description. If you click in the description, you can get access to it, but it's not a problem. If you don't have a physical copy, you can take notes on some paper as well. Yeah, it's a free lesson, so do not worry too much if you don't have the workbook to follow along. So chat, I'm just waiting to see what you guys think, and I'm going to get you started in case you guys are feeling a bit shy. So having a look here, honey, we've got honey. Honey is a liquid, so I'm going to pop that in my liquid tab. Let's see if anybody's got any. And honey is done. Earth would be a solid, for example. Yeah, this should be nice and easy. So looking forward to seeing your contributions in the chat. And juice is a liquid, very easy. And anybody else? Yeah, excellent, Kusal. Thank you for taking part there. Just waiting for everybody else in the chat. Lots of people said hello. So just get involved. That'll make the lesson more fun for you as well. And in terms of, yeah, good stuff, SB. Steel is a solid. Well done. So I'll put steel in here. Yeah, fantastic contribution from SB as well. Yeah, well done, Neil. Does crying over maths. Elites, you've got solid as rubber. Yeah, well done. So I'll put these here. Let me tick these off because I can see the chat is live and kicking now. Glass is a solid. Nice. What about gases, guys? Anybody have any examples of gases? And Nea Cosmic, thank you for coming back here as well. I'm glad you enjoyed it. We did this lesson in the summer school, so this should be very easy for you, Cosmic. But welcome back, Cosmic. And any other gases? Anybody have gases? Yeah, Adrian, good stuff. You managed to see oxygen is a gas. Perfect from Adrian there. Oxygen is a gas. Yeah, we've got glass solid, nice, and still sugar flour. Yeah, flour is also a solid. And let's spell flour properly. Yeah, excellent. I can see the chat is more awake now. Carbon dioxide is a gas. Excellent. Carbon dioxide. Okay, let's keep it going, chat. And we have carbon dioxide is your own example. So really, really impressed with you there, Tarangani. And let's see who else. Methane is a gas. Nice. So we cross off the ones we can get there. And nitrogen will be a gas as well. Let's find more gases. Nitrogen and methane. Nitrogen is a gas. Yeah, wax is a solid. Excellent. So wax is a solid at room temperature, but when you start to burn it and you heat it up, it turns into a liquid. Air is a gas. Yeah, nice. Air is actually a mixture of different gases. We'll get onto that as we get onto the main course. If you are signing up, that would be great. So we've done that. Fire is a weird one. So fire, I'll actually say fire is a weird one. Fire shows the effects, of combustion. So fire is actually not one of our states of matter. But well done. Iron is a solid. Okay, so I'm going to go through these quicker here. We have iron. We have water as a liquid. We have flour we've done already. And sugar we've done already. So I believe we've done all of these here. But what I want you to think about here is how do you decide which group every one of these belong to? How do you decide? What are you thinking about? Let me know in the chat. And Zerin, lovely to see you here as well. I'm just trying to say hello to everybody who is in the chat. Yeah, good stuff. Okay, so we have what would fire be considered as, Zerin? That's a great question. So fire is a mixture of one of the actually trickier parts that we don't see in year 9, but it's called plasma. Okay, so there's parts of fire that is plasma, but fire is a very, very interesting phenomena that you get to learn more about. It's not as simple as we think. Okay, but we'll cover a bit of plasma in today's session as well. Great question there from you, Zerin. So what we need to think about is the properties. So the properties is what we've used. Yeah, exactly, Elite. Combustion is a chemical reaction and fire is a sign of a chemical reaction. So good stuff there. But the properties is what allows us to put these into the right place. So over here, when we looked at our examples, you're looking at the properties. Is it hard? Does it fill up the whole container? Can you pour it, for example? All of these things help you to decide what state of matter you have. So we need to know that for a solid, so we're focusing on solids at the moment. For a solid, the solid will always keep its shape no matter where you put the solid. So you can grab a solid, you can take it, put it in a different container. That solid will always keep its shape no matter what you do. In terms of the volume, because the solid keeps its own shape, it will also keep its own volume. And if we work nice and quickly today, guys, we can do a Kahoot, which is a nice quiz, just to see what your knowledge is like and how you have kept the knowledge from today's lesson as well. So keep up the engagement here. And if you want, you can give me a head start on the liquid if you're thinking about these already. But if you look at whether a solid is able to flow or not, a solid cannot flow. Okay, a solid is not able to flow. Flow means you can pour it and it can move by itself. A solid cannot do that. Can you squash a solid? Not really. Okay, definitely not really. Yeah, good stuff, KT, as well. And what about a liquid? If you focus on liquid now, does a liquid keep its shape? Let's see what the poll says for you guys here. Yeah, good stuff. A solid can't flow. Well done. Neil does crying over mass. I'm going to do a poll very quickly. Can or does a liquid keep its shape? Let's see what you guys think. And quickly vote in the poll so we can see how we're getting on. Okay, SB says no. And Gamer Noob says a liquid is able to flow. Yeah, I agree with you there, Gamer Noob, for sure. A liquid can flow. We know that for sure. Okay, and let's see how the poll is going. Okay, I'm going to end the poll. Yeah, we have lots of votes in the poll, which is great. And the poll, quite a few of us said yes, but you need to be aware that if you have a liquid, do I have some liquid here? I had a bottle of water, which I've gotten rid of, but it doesn't keep its shape, okay? If you pour it into a cup, it will fill up the cup and take the shape of the cup. If you pour it into something else, it will fill up the container's shape as well. So it does not keep its shape. Yeah, it changes its shape based on where you put it. And it's really good. I saw lots of responses in the poll. So let's keep it going. And can you squash a liquid? No, you cannot. Okay, so Zerin, when you talk about the particles, yeah, be very careful. If you say the particles have stronger energy, it's slightly, I think it's a slight misconception. So just pay attention when we get to the particles here, just so you can help to fill in the gaps in any of your knowledge that you have. And for gases, gases do not keep their shape. Gases will fill up the whole container if they have the ability to do so. They don't keep their volume, so the volume of a gas changes depending on where you put it. So the gas will expand to fill up the volume of the container you put it in. And can they flow? Yes, they can. Excellent there, Gamer Noob. And can they be squashed? Yes, they can. They're very easy. So we can explain some of these properties using the particle model and the particle theory. So we're going to move on to that shortly. You should remember this from your year 7 and year 8 days. Okay, so when we talk about particles, a particle is the smallest part of a substance here, and you can think about it as being a single thing. Every single thing here is made up of particles, and we can draw them as you see in the diagram there. So the way these particles are arranged, the way they're stacked on top of each other, the way they might be far apart from each other, will determine the properties of what we are looking at. Okay, so swiftly moving on, see if you can remember what these look like. So what do you think the particles are arranged like? You can say it in the chat, that's absolutely fine. In a solid, in a liquid, and in a gas. And we're going to have a look at a model to help explain this as well. Okay, so in the chat, just let me know, and I will be very quickly showing you. I'll start with a gas. So we leave this one as gas. We'll have this one as liquid. And we'll have this one as solid whilst the chat gets loaded up. Yeah, excellent, SB. Perfect. Thank you for your contributions there, SB. So in a solid, they are tightly packed together, arranged in a nice order. Everything is touching each other there. In a liquid, they are also touching each other, but they're not orderly arranged. They kind of slide over each other like so, not so ordered there. Yeah, excellent, SB. And Elite says solid compact in form, liquid semi in form, but a bit disorganized. Yeah, I guess that will get you the marks there. And the gas, I would say randomly distributed, and the particles are moving in random directions like so. Okay, yeah, and they're very spread out. Adrian, I like the keyword spread there. Well done. And Zimchi, liquid is not close together. So in a liquid, they are close together, Zimchi, but they're not ordered. They're not like the solid where it's on top of each other. One is on top of each other. The liquid, they're kind of a bit disorganized. Okay, and the gases are not touching each other. That's absolutely correct. So what we're going to do is have a look at a model. I love using models in my lessons. So if you sign up for our main course, what you will see is a lot of new models, exciting models to help you to make sense of a lot of these concepts that you might not get first time in school. Okay, so let's have a look at one of my favorite models here. And this is the state of matter model. And we'll look at states here. Which state of matter is being represented here? In the chat, what state of matter do you think we are representing here? Just have a go. Let me know in the chat. What do you think is this state of matter? And as you have a think here, I am going to show you what happens. Yeah, excellent, SB, perfect. Good contribution so far, SB. SB is number 2. Kusal's jumped in now as well. Yeah, perfect. Yeah, well done, guys. Yeah, good stuff, Katie. We'll get onto plasma in a second. So you can see the solid here. The particles are vibrating in a fixed spot. You can see that very clearly there. They're vibrating in a fixed spot. And thank you, guys. I think there's a slight lag in the stream, so that's why it takes a while for you guys to respond. But keep it up. I really appreciate it. So we've got solid here. They're vibrating on the spot, and you can see that they're all arranged in a nice order. If I click liquid, you'll see they're still touching each other mostly, but they can slide over each other as well. Every now and again, you'll see some of them are able to escape the bulk. What process do you think is happening here where some of these can escape the bulk and move off away from the main liquid here? What do we think is happening to some of these? Yeah, so this is exactly what would happen, for example, when it rains. If it rains and you have a puddle on the floor, the ones on the surface sometimes get enough energy to escape. And when they escape, they become a gas. Even though all of this mostly is a liquid, some of them can escape to become a gas. And what is the name of that process there? Just to give you a challenge. Now we're going to look at the gas. Yeah, well done, Zerin. Perfect, Zerin. It is evaporation there. Some of the liquid can evaporate over time. Okay, and that's why puddles, even though it's not boiling, it's not 100 degrees outside, the rain puddle will still evaporate over time. If you give it enough time, all of these will be able to evaporate. Yeah, great knowledge from you guys here. But look at the gas. Whoa, look at that gas. Everything is moving around. The particles are moving around in different directions. You can see it's very random. And they're filling up the space of the container. You see that container there? They're filling up the space of the container that we have there. Okay, whereas the liquid would fill up the space and would take up the shape of the container, but doesn't fill up the whole space. Be very aware that the liquid doesn't fill up the whole space, but the gas fills up the whole space and takes the shape of it there. Whereas the solid has its own shape, has its own volume. Okay, so that is it for our models here. I'm going to exit this very quickly. And as I said, there's a Kahoot loaded up for if we go nice and quickly. I think we will. And let's move on to then trying to describe these. So what I would like you to do, let's label these nice and quickly. Solid, liquid, and gas. Can you try to put the keywords here, these keywords, into the right boxes here? So can you try to put the keywords into the right boxes? So for example, I'll give you a head start. Very easy. I would say stuck goes with liquid, for example. Okay, that's an example of how you can respond in the chat to let me know which ones you think I should put where. And once you've done that, I will then write a bit more. Yeah, good stuff from Gamer Noob. Yeah, close. Close actually is for liquid. So I'll put this one here. Close is for liquid. Solid is fixed. I'll give you that one. And what else we've got? Far apart. Yeah, nice. So for the gas, far apart. Let me tick these off whilst the chat goes off. So far apart, we've got fixed, we've done close, we've done there as well. Vibrate, yeah, nice. So somebody said vibrate as well. And that's SB, well done, SB. SB, you're really taking over the contributions here, SB. Keep it going, I love that. And Morire, nice one, Morire. Thank you for getting engaged in the chat. Zimchi, you're correct as well. Ilham, hello, Ilham. Hello, hello, welcome. And Viran ordered, yeah, which one does ordered go in for? Yeah, the chat is kicking off W chat today. And ordered, which one does that go to? Solid there, well done, Neil. Does crying over AQA, so ordered. Yeah, nice. So let me tick that off. We've got ordered, we've got vibrate. What about move? Where are we going to put move? Yeah, move you can put for liquid as well. Okay, and stuck, we said stuck was going to be for liquid. All right, perfect. And thank you all. This is how I'll do these. And in a different color, I'm going to switch to my blue now. I love a bit of blue. And what we're going to do is say that this has an ordered arrangement. That means everything is in order. It is arranged orderly. They vibrate in fixed positions. Okay, so they vibrate on the spot. And for a liquid, they are close together. The particles are close together and they are stuck next to each other, so they can slip and slide over each other. Let's see what the chat's saying. Okay, good stuff. Hello, Samitha. Welcome to our free lesson today. And four gases, they move in random directions, and they are far apart with lots of gaps. Okay, so I'll leave this here for you to have a bit of a look at. Remember, I'm going to be testing your knowledge very shortly to see what information you have managed to hold on to. I'm also going to give you a quick quiz at the end of this, and then we're going to have a go as well. And Viran, stuck, wouldn't stuck be solid? You can put stuck for solid as well, but I just wanted to rearrange these around so that the words were a bit more spread out. Okay, so you can say that Viran for the solid, but I think as long as you're clear on the clear concepts here, then it's absolutely fine. Yeah, I can see you've got a good argument there. Okay, so moving swiftly on, let's have a look at the interesting one, which is plasma. So somebody mentioned fire before as well. Very hot flames can be classed as plasma, but plasma is an extra one here you can impress your teachers with. So you can say this to your teacher to impress your teacher here. And apologies, let's get back to the slides. We were here. Okay, to impress your teacher. And I will not write on the top there. I can see it doesn't like me writing there. But if you give in more energy, if you give more energy to a gas, what you can do, you can turn it into something called plasma. So the sun is a type, and Lena, great knowledge. That's absolutely fantastic. I was expecting somebody to say this here. So plasma, there are different types. So plasma is what holds your blood together. But remember, in science, sometimes the same word has different meanings. Who can think of another word that has a different meaning in the different science? So for plasma in biology, that's what holds your blood together. That's what all the organelles in blood are held together by, sorry. But plasma in chemistry and physics is slightly different. Okay, yeah, excellent. Lightning is an example, stars as well, elite, great knowledge. But you need to remember that you have to have enough energy to remove electrons. Once you can remove electrons from a substance, then you can start to form this thing called plasma. And examples here, let's change the color. I'm going to go with green now. So examples would be super hot flames, very hot flames. That's why stars count. Stars have very hot temperatures there. Yeah, work is another word. Yeah, well done, Lena. Cell as well, for example, a cell in biology is different to a cell in physics, for example. So be aware what subject you're in and how those keywords could change. But that's also a great point. And plasma from the sun would be very dangerous. Yes, very hot. So you've got the sun, lightning as well. Lightning is classed as plasma. And neon signs. Neon signs are also classed as plasma. Let me write this a bit clearer for you so you can see. Neon signs as well are classed as plasma. Okay, perfect. So we are nearly there. You are all doing a fantastic job in the chat. We're just going to answer a few questions together just to see how you're getting on. But I have a challenge for you. So who knows what oobleck is? Who knows what oobleck is? Okay, oobleck or cornstarch, what state of matter is it? Solid, liquid, or gas? And let's give you one more option here. Okay, so there's a poll in the chat for you. What state of matter is oobleck? Yeah, nice. Yeah, what is a cell in physics? A cell in physics provides energy for the circuit. Yeah, it provides energy for the electrons in the circuit. So a cell is similar to a battery, whereas a battery is made up of more than one cell. Yeah, so you will come across lots of these words that have different meanings in the different sciences. Okay, have a go at the poll. Let's see how you guys are getting on. Oh yeah, morire. Perfect. Yeah. Shout out to Morire there. That is great knowledge. So that's exactly what I'm about to tell you shortly. But who knows the name of this type of substance? This type of substance. Let's have a look. Yeah, so I'm giving you a bit more extra information that you can use to impress your friends and your teacher when you go through this. Yeah, KT, excellent. That's exactly it. Shout outs to KT there. I'm going to end the poll. So oobleck, if you look in the poll there, some people said solid, some people said liquid. Well, it depends, okay? It depends. So oobleck is sometimes a solid, and sometimes it's also a liquid. Sometimes a solid, sometimes liquid, and it depends. It depends. So this year is very fun to play with actually. Yeah, if you've got any younger siblings as well, it's a nice thing to do. You can color it. You can make lots of different shapes out of it as well. And there's a cool video, the slow-mo guys, you can go and watch as well. Not both SB. So it depends. This is called a non-Newtonian. And who can tell me who this is named after? Newtonian. Who has that name? It's called a non-Newtonian substance. And yeah, you didn't get an option, Samitha. Yeah, that's because I just wanted to use this to get people to think. So don't worry, it's not a trick here. It's just to get you to think about what we've got in oobleck. So it's called a non-Newtonian substance, and it switches. It can switches its behavior. And yeah, exactly. Isaac Newton, who was the scientist who did a lot of work around forces. But non-Newtonian substances switch behavior depending on how much force you're applying, and yeah, depending on the force applied. So with oobleck, if you touch it very lightly, it can behave as a liquid. But if you smack it, or if you apply a quick force and a lot of force very quickly, sorry, then it can behave as a solid. So under force applied. So it's very interesting, very cool. So we've seen plasma and we've seen non-Newtonian substances as well, but be aware that what we need to focus on is solid, liquid, and gas. So to check your knowledge on solid, liquid, and gas, I'm going to give you a few questions very quickly before we have a go at a Kahoot, just to see who has learned the most today. I'm really excited to see who I'm going to be giving a shout out to. And then we'll be back in the lesson to finish up as well. We have plenty of time. For now, please do not say anything in the chat. I am going to create polls here just to see how we're getting on. And I'll use this to explain what we're doing. So just bear with me. I'll be making the polls very quickly. And here, perfect. Okay. Yeah, it was very quick. The lesson's not over yet. I'm just letting you know that I'm testing your knowledge now. So let's have a look here. Yeah, do not respond in the chat, please. Do not respond in the chat. Yeah, for now, do not respond in the chat. We'll use the poll just to see how we're getting on. Okay, we've got 20 votes in the poll, which is fantastic. Let's see if we've got any more. So refrain from saying it in the chat just so we can check how people are getting on. Yeah, this is amazing. Yeah, 100% in the poll. I love that. So the ones we need to focus on are solid, liquid, and gas. Yeah, water is an example of a liquid, but is not the traditional state of matter, and air is an example of gas as well. And ice, water, and vapor, these are all different states for water. Yeah, and liquid, gas, and plasma. Plasma is the only one that's not the traditional state of matter. Yeah, good stuff here, guys. Okay, and I'm going to give you another one, another poll. Let's see how you get on. And this should be quick for you now, a lot quicker. And last option for you. Okay, let me know your thoughts, please. Off you go. And I'll see what the chat is saying. Yeah, so Gamer Noob, Kahoot is amazing. I'm going to show you Kahoot today, and hopefully that will help you to see how you can bring your learning together as well. It's a really fun way to bring some competition to the learning, but it's also really helpful for me to see how you're getting on with the content as well. and the lesson ends at 7:50, so we have quite a bit of time here. And let's have a look. I think everybody's smashing it here. We've got 20 votes, so I'm going to end the poll. And yeah, Neil does crying over AQA. We've got second here. And sorry, there's three. Yeah, I'm only using what I see on your YouTube account. So apologies for getting your name wrong, Sri. Yeah, I will get it right going forward now. Okay, perfect. We've got 200% here. We've got 200% absolutely banging here. So the next one says, which state of matter has a definite shape or volume? For sure, solid. Liquid has a definite volume, but not fixed shape, not fixed shape. And remember, gas takes the shape and volume takes the shape plus volume of the container you put it in. Okay, so you need to be aware of that there. And moving on, I'm going to give you a couple more just to check how we know how we're getting on here. Okay, good stuff, chat. Yeah, I really enjoy how everybody's taken part very nicely today. And the chat is very constructive. People asking really good questions, which is good. Shows how we have scientific minds here. Everybody wanting to find out more and sharing their knowledge with each other as well, which is great. So one more poll. Let me know what you think. Oh yeah, we have a bit of a split on this one here. Let's see how it's going. This is interesting. So I can see the results before you guys. I'm not sure if you can vote twice. So we've got 22 votes. That's more than the last time here. So let's see. Okay, people are changing their mind in the poll. I see, I see. Okay, I'm going to end the poll now. And here, in which state of matter do the particles spread out to fill the whole container? So 27% said both liquid and gas. I'm glad nobody said solid, but I can see you might not be sure between gas and liquid. So it's both. It's both. Yeah. So if you put gas, it's still correct, but the most correct answer is both. So I would still give you half a mark here if you put gas or liquid, and that's because these are referred to as fluids. Okay, fluids. A fluid is something that can flow, a substance that can flow, a substance that flows, so it can move from one place to another. So here, in this case, the right answer is actually not both. I'm going to go back. I'm not reading the question properly. It said spread out to fill the whole container, the whole container. Okay, so the answer is actually C, right? But liquids and gases are called fluids, but the one that fills the whole container, so remember, the gas moves in all random directions, whereas the liquid will fill the container and take the shape of the container, but there's still lots of space left over here. It's not completely full. Yeah, so if you put gas, you are absolutely correct. Yeah, the correct answer is gas. I was thinking along fluids and thinking about the ones that take the volume, change the volume, and change their shape. Okay, but when you talk about taking the space of the whole container, that has got to be gas. Yeah, well done, guys. Good for those who put gas. Okay, true or false now? True or false? Yeah, don't worry, we'll have another chance in the Kahoot at the end of the lesson to really impress me with your knowledge. So we're nearly there. So what I want to know is particles in a solid cannot move. Think about this very carefully. Think about this very, very carefully. Yeah, this one is a little bit of a trick question. So be aware. Have a think before you answer. And Sri, yeah, I love a Kahoot as well. Hopefully you'll win the Kahoot, Sri. We'll see. We'll see. Yeah, it should be fun. And what I'll do is as we go along with the Kahoot, I'll try to explain each step of the way so that we can all understand how we're getting on. Okay, I'm going to check the poll now. Yeah, so I can see a few people are thinking about this here. And Tarangani, you are absolutely correct. Yeah, so here they are vibrating. Yeah, they're vibrating. Remember, a vibration is still a movement. Okay, so they can't flow, but they're stuck on the spot, but they're still vibrating. They're still moving from left to right in a fixed position. So vibration is still a movement. So I would say that this one here is false, but we need to be clear that they vibrate in a fixed position. They vibrate in a fixed position. Okay, last one, and we'll do a long form answer. Yeah, they still move a little bit. A vibration is a small movement. Okay, so that's why this is false. Okay, this one here is for gases. This is a poll as well. So please do not write this in the chat. Do not write in the chat, please. It's the last poll. Last poll. And have a think as I get it ready for you. Yeah, well done, Sri. Really impressed. Yeah, Sri, I'm expecting you to do really well in the Kahoot later then. Yeah, we'll see how we get on. Like a bit of competition. Let's see how people do with this poll though before that. Oh, yeah. We're getting some answers here. We've got 12 votes. Nice, 13 votes. Yeah, the votes are going up and up. I can see people are taking time to think as well. Well done. And Brianna, well done, Brianna, as well. Good stuff. Okay, I'm going to end the poll now very quickly. We've got 22 votes. I think there are 23 people in the chat, which is good. Yeah, make sure you subscribe to the channel as well. And let's have a look. So most of us here have gone for fixed volume. It's not a characteristic of a gas. Takes the shape of the container. Some people put that. Some people said they are far apart. So remember, read the question carefully. It says not for a gas. We have this here where the particles are far apart, moving in random directions. So they will take the shape of the container for sure. They can move freely for sure. They are far apart for sure. Having a fixed volume, however, they do not have. Yeah, gases do not have a fixed volume. They can move and fill the volume of wherever they are. So very quickly then, let's try and have a shorter written response question, longer written response question, sorry, but it's a short one. So explain why gases can be compressed, but solids cannot. So you need to make sure you refer to gases. Okay, and then refer to solids in this as well, because we're talking about gases and solids, so you need to talk about both. So let me know in the chat, what do you think? Talk about both gases and solids here. And don't forget, you've got keywords over here you can use. I will answer mine in green to change the colors up a bit. Answer in green. So in the chat, anybody wants to have a go if you're brave enough? Let me see. Yeah, we've had a W chat already today, so let's keep it going. You guys have been fantastic in the chat. Really, really impressed. And I'm really hoping that a lot of you are going to be on the main course. I'll be teaching the Year 9 chemistry course as well. So if you're doing that, then hopefully I'll be seeing you again and not just today. Okay, I will support you with this one here. So for gases, oh, nice. Yeah, good stuff there, Tarangani. So Tarangani says that the particles, they move freely and flow easily, but solids can't. So it's very close. So the particles. So remember, compressed means squished. You want to squish them. So the particles in a gas have a lot of space between them. So because they have a lot of space between them, they can be compressed very easily. They can be compressed easily because we can push them closer together. Yeah, so to compress is to squish. You can bring them closer together. They can be compressed easily. Excellent. Okay, let's see what people are saying. Gases could be, oh, the chat's going off now, so I love that. Let's go back. So because solids have fixed volumes, whereas gases do not, that's also great, Adrian. Yeah, good contribution. That's correct. And not being sure, that's fine. The gases can move freely into space, but the solid can't. Yeah, well done, Viran. And Yep, so it's all about the spaces in between them. Yeah, this is because the particles are free to move. They have no fixed shape. Yep, but we have lots of space in between them. Yeah, so try and use my keywords to help you. Elite says gases can be compressed and solids cannot because the particles are tightly packed and hard to compress. Yeah, Elite, I like your question, your answer there. That is an elite response. Yeah, I see what I did there. And gases can be compressed. This is due to the state of particles. They flow. Yep, so I'll tell you for solids here, the particles in a solid, it's all about the spaces. The particles in a solid are close together. See them very close together. And because they are close together, they have no spaces, with no spaces between them, very little spaces. So they cannot be compressed. They cannot be squished. So there's no space. There's no space between them to squish them together. They cannot be compressed. Okay, so that is us going through all of the states of matter and their properties very quickly. We're doing amazing for time. We're going to have a go at a Kahoot. So in order to do this Kahoot, you need to make sure that you're ready to join. What I don't want to happen is for anybody to miss out on this Kahoot. So I'm going to give you some time ahead of time here to get prepared. You need to type in kahoot.it onto your phone or into a browser, a separate tab, but you need to make sure you can still look at the stream so you can get the code. So you will type in kahoot.it into your address bar. Okay, you go to your address bar, you type in kahoot.it. I'll show you. And let me open Chrome. So if you have Google Chrome, for example, you type in at the top in the address bar, kahoot.it. Okay, you type kahoot.it and you wait for me to give you the pin. So please make sure you are on kahoot.it. Yeah, just waiting for everybody to be there. Perfect. So once you've got that, then this is our pin. This is our game pin. So you need to type in this pin. And the pin will allow you to join here. Yeah, well done, Sri. Just jump in with the pin there. The pin is 72241. Or you can scan that code there, that barcode there as well. Yeah, nice one, Lena. I love that. Everybody loves a Kahoot. I can see that. Okay, so just waiting for people to join. We've got one person, two. Yeah, nice. Everybody's jumping in now. I think there's 23 of us here. So we see how we get on. Yeah, nice. How many people do we have? 17. Okay, make sure you jump in. It's going to be very fun, very cool. Yeah, nice. We've got 21. I think when we get 22, I'm going to... Oh, we've got 24. Oh, there are more people in the chat than I realized. Ah, these are the people that are hiding in the chat. I see, I see. Okay, so are we ready? We good to go? There's 35 people watching, but only 25 in our Kahoot. That's fine. You can still take part in the quiz. You'll see the questions on the screen, and you can still have a go at trying to answer it. You'll also see it on your screen at home, and it's a really good way to get engaged in the learning once it's finished. So in the main course, if you sign up, we will do a Kahoot sometimes if there's time. Today, because the content is quite easy, I'm going to give this Kahoot so that you can have a go. We won't do it all of the time, but it's very good to review what you've done. Yeah, nice one there, Gamer Noob. Yeah, who do we think is going to win? Mavis, who do you think is going to win? Yeah, who's confident? If I had to bet on someone, I've got it in my mind. Let's see if they win. Yeah, so good luck. I'm going to get this started now. I think most people have joined. If you have not joined, then you can still take part on the screen. So let's get started. Let's go. Okay, so it begins. Good luck. Read the questions carefully. And if you are at home and don't have the answers or don't have it on your phone, you can still take part. So please make sure you're still engaging to see what the correct answer is, and I'll talk through each one. Nice. Got 3 more seconds. Okay, perfect. Almost a full house. Obviously a gas. They're moving randomly and there's lots of space between them. And who have we got here? Yeah, Tarangani's at the top there. Love it. Yeah, no problem. I know there's a slight delay on the stream. Yeah, perfect. You guys smashed this one. Oh, it's getting tense at the top. Yeah, have a close think. Don't get confused by this one. They're trying to trip you up. Yeah, excellent, guys. Well done. Because they're still touching. Yeah, if you see them touching, but they're not in a structured arrangement or ordered arrangement, then it has to be a liquid. And Shivani smashing it there. Yeah, we're speedy. Nice. Remember, solids only vibrate on the spot. Solids are only vibrating on the spot. Majority of us are smashing this here. Oh, yeah, there's a big change there. Well done. Bella's on the podium now. Oh, it's looking good. And let's see, 10 more seconds. And oh, that one's a bit of a 50-50. So particles arranged regularly, remember, ordered. If they're ordered and in regular rows, then that is going to be your solid. Yeah, and Shri, there is a lag here. There's a lag so that the video can get uploaded in time. So every stream will have a slight lag, but it's absolutely fine. You can still get on. Yeah, you can still get on. Okay, Maeve, well done. At the top now. Oh, nearly there. We've got lots of answers from people here. Okay, let's see how you guys are getting on. Okay, so taking the shape of the container, remember only fluids can take the shape of a container because they can flow. Only liquids and gases can flow. Yeah, it's definitely not gases only, and it's definitely not liquids only. Gases only take the volume of the container. Liquids keep their volume, but both of them can take the shape. Okay, they can take the shape. And Neil does crying over AQ. I'm not sure. That won't be happening yet. The correct answers are locked into the game. So if you get the correct answer, it will definitely register it. So just take your time. And let's see, how is it going? Yeah, excellent. So having a look at this here, most of us got this right. No, actually, most of us got this wrong. Fixed volume. Yeah, remember the volume of a solid and the volume of a liquid is fixed. Yeah, well done for those who were able to get that. Let's see, there should be a shake-up now. Shanea's up on top. Well done, Shanea. Still have a chance to bring it back. 2 more questions. 2 more questions to rescue you here. Yeah, 2 more questions. Oh, very close. Nearly got 4 marks there. Shania has really taken a lead on that one. Well done, Shania. Unlucky Ohem. It happens. It happens. Yeah, it is fun, but remember, the whole thing about this is making sure you're learning from it as well. Yeah, but I can see you've really taken on the content we did today. So hopefully when you're back in school, this will help you in terms of having a strong foundation for chemistry. Not just chemistry, but states of matter is important for physics as well. Yeah, getting closer. So here they have weak enough that they can slide over each other. Remember, it's the liquids that slide over each other. And oh yeah, Meow is getting closer. Shania, I think Shania is one, but let's see. No fixed volume and takes the shape of the container. Take your time. No fixed volume. No fixed volume. Don't want to give it away. No fixed volume. Yeah, perfect, guys. Yeah, remember, a liquid still has its fixed volume. Yeah, remember, a liquid still has its fixed volume. But let's see our winners here. Oh, in third place on the podium we have Brianna. Well done, Brianna. Excellent. Give you a round of applause. Yeah, amen. Well done. But at the top, W's in the chat, please, for Shania. Shania absolutely smashed it. Let's give Shania a round of applause. W, Shania, and well done to our runners up there as well. And W for Shania. Well done, Shania. Shania absolutely smashed it. You are the winner for today. Okay, so let's go back to our